Before we dive into this particular exercise, I want to note that the MAC address table is one of those things in networking that is known by multiple names. You don't hear bridging table really often. That's really quite a legacy term, but you do hear it called the switching table and the CAM table, really more than the other two, content addressable memory tables. So you should be ready to see it called a MAC table, a switching table, a CAM table, or a bridging table on your exam. Again, here's our diagram, and we're going to start this one with host A sending a frame to host C. So the frame comes in on port 1, looks at the source MAC address, and asks itself one simple question that it asks itself time and time and time again. Do I have an entry for this MAC address in my MAC address table? There's no gray area. There's either an address or there isn't. Well, we just turned the switch on, and in the previous MAC address table, the only addresses we saw would be the ones you would expect to see, the ones for the CPU. So there was no dynamic entry at all. So in this case, the switch would make an entry for the all A's MAC address, and the table would now look like this. And you can see that it's going to show you what port each entry is found off of, the dynamic entries. Something called a VLAN over here. We're going to talk about that a little bit later. Here's the MAC address and the type, and notice that it is dynamic. The CPU entries are always going to be static. Now, after all of this, we finally get to that frame forward decision. Remember that? Well, here are the choices again: forward, filter, and flood. And the switch is going to now look at the destination MAC address, which is the all B's address, and ask itself another simple question. Do I have an entry for this destination MAC address table in my table? That's really it. That's the question. The first question is, do I have an entry for this source? And the second question, do I have an entry for this destination? Now, the answer is no, of course, here, because we just have the one dynamic entry, and that's the all A's address. Well, when the answer is no, the switch floods the frame. And it's the same thing as a broadcast, really. A copy of that frame will be sent out every single port on the switch except the port the frame came in on. Now, this particular type of frame we're discussing here is an unknown unicast frame. And I know I've got it on the screen here for you. I like to ask that in question form too, though, because when I first heard that term, I thought, well, if it's unknown, how do you know it's a unicast? Well, the frame is a unicast itself. It's destined for one particular host, but the port that leads directly to that destination is unknown. And you know what the switch is basically saying in this situation? I don't know where this destination is, so I'm going to make sure it gets where it should be going by sending a copy out every port except the one it came in on. Flooding ensures that the frame is going to get to the host that needs it, and it also guarantees that the other hosts in the LAN are all going to get the frame, which is a total waste of our bandwidth and switch resources. We don't mind this behavior when a host is first added to the network, or when a switch is first added to the network. We expect it, but we don't want it to happen a lot after that. And again, if this was a 64-port switch, and we have a host on every port, which is very common in today's networks, that means in this case the switch would have to send 63 copies of any flooded frame, and 62 of those, if it's an unknown unicast, are going to be totally unnecessary. Again, it's not something we'd mind at the very beginning of the process, whether it's adding a host or a new switch. But after that, we'd rather not have a lot of flooding. It's not very effective. And as you're about to see, we likely won't, because now host C is going to respond to host A with a frame of its own. So here comes the frame back in. The source is the all C's address, and the destination the all A's address. Now, the switch begins the process by checking out the source MAC of that frame, like always. Is there an entry for the all C's? Well, this time, notice that I used the option dynamic on the end of show MAC address table. That's a great way to filter out all the static entries and just look at the dynamic ones. A very handy little tool there. Well, there isn't one, so the switch is going to create one, and there you go. So now there's an entry for the all C's MAC address, and it's found off port 2. Now we're going to see those dynamic entries in the table work for us, because the switch now checks the MAC table for the destination of that frame, the all A's address, and there is an entry for that one showing that host to be found off port 1. So what's going to happen now? Well, there's no reason to flood this frame. No reason at all, because it is a known unicast frame. And instead the frame will be forwarded out only that one particular port it needs to be sent out. Just that quickly, the switch is starting to put a MAC address table together, and just that quickly our frame forwarding has become much more efficient. Now, if host A responds to host C, the switch would have an entry for host C's MAC address table where it didn't have one earlier, and frames from host A to host C will now be sent directly out port 2 rather than being flooded. Now, we're going to jump ahead to another scenario where the topology is the same, and we're assuming at this point the switch has a dynamic MAC entry for each host. Now, please note again, this is not a topology you're going to see in real-world networks. That hub is stuck in there for a reason. You're about to see what that reason is, because we have a very unusual setup here where hosts A and B are both connected to a hub that in turn is connected to a switch. Well, to that switch, both hosts are found off port 1, and that leads us to our third possibility for incoming frames. Now, when host A sends something to host B, sends a frame, host B will get a copy of it through the hub, as will the switch. The switch is going to see the source MAC address, look for an entry, C1. Then it looks for the destination MAC, the all B's address, it would C1, and then realizes that both the source and destination are found off the same port. Now, on the extraordinarily rare occasion that this happens, the switch is going to filter the frame, which is a fancy way of saying the switch will simply drop the frame. That's really it. Now let's review these three switching decisions and when the switch uses each one. And I do have an addendum to that filtering definition. With flooding, that happens when the switch has no entry for the frame's destination MAC. We know now when a frame is flooded, a copy of it is sent out every port on the switch except the one it came in on. Unknown unicast frames are always flooded. Forwarding happens when the switch does have an entry for the frame's destination MAC, and when a frame is forwarded, it is sent out only the port that leads to that destination MAC. Filtering happens first when the source and destination MAC addresses are known to the switch and are both found off the same port. Now, technically, filtering also occurs when a frame is not sent out a port because the destination is a known unicast. For example, in the previous discussion, let's say that A is sending a frame to C and all 4 MAC addresses are known by the switch. You could say the switch is going to filter the frame as far as port 3 is concerned because, of course, it would not send a frame at port 3. I've seen that usage before. I'm not crazy about it because when I think of filtering on a switch, and that's just always the way it's been, it's because source and destination are found off the same port. But you really can use the word filter for drop the frame at any time. So again, if A was sending a frame to C and all addresses are known, you could say the frame is being filtered at port 3 because there's no reason for it to go to D. And let's see, that's about it. Actually, this is a celebratory time too, because you're probably already tired of hearing the phrase, accept the port it came in on, but it is important because it seems very rare that we get to say never in our networking studies, and that's because it is very rare. But this is actually one of those times. Switches never send a frame back out the same port that the frame came in on. Now, I mentioned this MAC address earlier, and I wanted to put it here again. In addition to the flooded frames, there's another type of frame that is sent out every port except its arrival port, and that is a broadcast frame. Remember, broadcast frames intended for all hosts. It's like a radio broadcast, and the destination MAC is all Fs. Doesn't matter if it's upper or lowercase because case does not matter in hex. Now, a question you probably had when you were watching those dynamically learned MAC addresses when we were talking about them, we'll see them in action too. When I was discussing those, not going on about them, discussing those, that sounds better, I'm sure this question entered your mind, well, how long do those dynamic addresses stay in the table? And that is a great question. The default aging time for dynamically learned MAC addresses is 5 minutes. And that timer goes back to 0 anytime a frame comes in with that particular source MAC address on the same port. it's going to refresh it and say, okay, I just heard from so-and-so. Let's set the timer back to 0. So in short, as long as the switch hears from a host within any given 5-minute period, the host MAC address stays in the table. Now, as always, with time-based iOS commands, be sure to use iOS help to check the unit of time that particular command uses. Don't fall in the trap of thinking you've got every command memorized and all the time values memorized. I realize if there's a particular command you use a lot, you might have that down, and that's fine. But the key here, and you'll see this in action very shortly, is that with some time-based commands with Cisco, you're dealing in seconds. Sometimes you're dealing in minutes. Sometimes the command wants the information in seconds and hours and minutes. And it can lead to the wrong result if you're not sure of what that particular command is asking for. Now let's say that I asked you on an exam, job interview, doesn't matter. Let's say that we wanted to double the MAC address aging time. Well, the first thing you would need to know, of course, is what is the default, and you've got that down now. It's 5 minutes. What if you already knew the iOS command to change that value, and that command is MAC address table aging time? You might be tempted just to enter or write down whatever, MAC address table aging time 10. And that would be incorrect. It would be really incorrect because iOS help shows us that particular time, that time unit for that particular command is seconds, which means that the proper command would be MAC address table aging time 600. I'm actually going to show you that on the live equipment here before we talk about anything else. And I'll probably warn you about this again too, because I strongly recommend you use iOS help anytime you've got a numeric value in a command. And especially your time-related commands, because you've got seconds, minutes, hours, days, etc. And if you're putting in 3 days and you mean 3 hours, that's a pretty big difference. And also, of course, on the exam, it would mean you missed a question, so we don't want that either. So use iOS help. Actually, before we break for that lab, let's go ahead and take a look at this, and I'll show you this live as well. Another great thing about letting the switch do the work as far as learning the MAC addresses is that switches will dynamically adapt their MAC address table when there's a physical change to that switch's connection, and that saves you a lot of work and a lot of hassle. And let's take the switch where host D is just connected to port 3. And as sometimes happens in life, port 3 goes down, and we need to get the host connected to that switch back on the network as soon as possible. Now with dynamic MAC entries, all we have to do is plug the cable into an unused port and we're all set. Because as soon as frames come in from host D on the new port, the switch realizes this and it's going to do two things. It's going to remove the host D to port 3 mapping from its MAC table right then and there, and then it's going to add the host D to port 4 mapping to its MAC table. So that's a pretty good deal. It's going to adapt to it dynamically, and we will take all the dynamic adaptation that we can get. Now, I'm going to go ahead and we're going to move to the next video, and as we start a topic there, I'm going to bring the live Cisco switch up first, and we'll see that particular command, iOS help in action, maybe look at one or two others. I'll see you on the next video.